All right. Unit 9, chemical reactions. You thought I was going to get loud. Got to change it up. All right, so let's get started. What is a chemical equation? Well, that just represents a chemical reaction. We're going to go into various chemical equations. Chemical equation consists of reactants reacting together, producing products. We have reactants on the left side and products on the right side. That arrow means yields. Reactants and products are separate from each other with a plus sign. And let me show you what I mean by that plus sign. So here's some common forms of chemical reactions. A plus B, reactant A plus reactant B yields C. See that plus sign? That's what I was talking about, how we separate reactants and products on the same side of the yield sign. Here's A yields B plus C. There's that plus sign. Product B plus product C. And then here's another example. A plus B yields C plus D. So chemical equations can be written as word equations or formula equations. So you're going to have to remember everything we taught you before. Doesn't go away. When you're given a formula equation, they either would be balanced or unbalanced. And in this class, whenever you have an unbalanced formula, you're going to have to balance it. And we'll talk more about that later. So here's an example of a word equation. Iron plus oxygen. It's written out, the actual word, not the formula. Yields iron 3 oxide. There's those Roman numerals again. You have to remember that information in order to decide when iron and oxygen reacts, what will it produce? Here's the formula equation. Iron plus oxygen, notice how it's O2, yields iron 2, oxygen 3, or iron 3 oxide. Given this equation, you must give me the word equation. Given the word equation, you must give me the formula equation. You need to be able to go between both. Now, this equation is not balanced because we have 2 iron on the product side and 1 on the reactant side. We have 2 oxygens on the reactant side and 3. So we're going to do some sort of multiplication, and we're going to go further into that. But when it's balanced, you're going to have 4 iron plus 3 oxygens, O2s, yields 4 irons on this side, 2 times 2, and 3 times 2 oxygens. So we have the same amount of irons and oxygens on both sides of the yield sign. This is a balanced equation. And notice these symbols here, S, G, and S. We're going to get into what those mean later. All right, now. The symbols in chemical equations, what do they mean? Well, S means a solid, in parentheses, of course. What would the L mean? Liquid. What would the G mean? Gas. What would the AQ mean? Aqueous. If you don't know what aqueous stands for, that means it's dissolved in water. Good old H2O. So, reversible reactions. This arrow means it goes to products, can go to reactants, and reactants can go to products. It goes both ways. And all equations can do that. In chemistry class, majority of them are just going to go one direction, and we're going to leave it at that for high school. Now, heat, when heat is added to a reaction, notice how over the yield sign, you either have the word heat or you have the delta Greek symbol, the triangle, which is in chemistry class or in science classes, it is delta, which stands for heat. Now, PT over the yield sign means it's a catalyst. What is a catalyst? That is anything, a substance, that speeds up in a reaction. So if you add a catalyst to a reaction, you're speeding up the reaction. Now, let's practice to change word equations into formula equations. Follow the flow chart. So let's take a look. You need to ask yourself, is the substance in my chemical equation an element? If it's an element, break it down into a monatomic or diatomic. Monatomic means one atom. Diatomic means 2 atoms. So if it's monatomic, just write the symbol. For example, if it says sodium, you write Na. Or if we ask you for the word, if you had given sodium Na, you write the word sodium. Now, diatomic. If you have oxygen, iodine, nitrogen, chlorine, bromine, fluorine, these right here, they always come as diatomic. And to remember them, think of Brinkelhoff. You have bromine, iodine, chlorine, and fluorine, which are halogens. Then you have oxygen, which is right next door to fluorine. Then you have nitrogen, which is right next door to oxygen on the periodic table. And of course, hydrogen special hanging out over there on group 1 on the periodic table. But remember, whenever you see any one of these, they're always going to be diatomic. They're always going to come in 2. Like when we had O2 on the further example in this lecture, iron, oxygen, it was O2. Why? Because oxygen is diatomic. It's always found with 2 oxygens. Like I just said, subscript 2. For example, if you see the word bromine and you want to put that in a chemical equation, it would be Br2 because bromine is always diatomic. If it's monatomic, everything else on the periodic table would just be its symbol. If it's one of these, Brinkelhoff, they always come as 2. Another example, hydrogen. If you see the word hydrogen in a chemical equation, it is H2. But it has to be by itself. It can't be it can't be in another compound. You could have one hydrogen in another compound, but when hydrogen is by itself, there's going to be 2 of them. Whenever Brinkelhoff, any one of these is by itself, there's going to be 2 of them. So, is the substance a compound? So over on this slide, we have, is it an element? Over here, is it a compound? If it's a compound, which means more than one atom bonded together, ask yourself, ionic. Guess what? Ionic and molecular. It's not going away. Everything we taught you, you have to remember. What does ionic mean? A metal plus a nonmetal. So if it's ionic, you balance the charges. You're going to have a metal, then a nonmetal. So for example, calcium chloride. Look on your periodic table, find calcium. Calcium is a +2. It wants to lose 2 electrons to become a noble gas, or to look like a noble gas, to become as stable as possible. Chloride, ide, meaning it is now an ion, wants to gain an electron, so it's a -1 charge. To look like a noble gas, it needs to gain an electron. So we say Ca +2, Cl -1. And if I went through that kind of fast, ask us in class, this as a review, because you should already know this. Now, molecular. Of course, chlorine is, there's 2 of them because it is a diatomic atom. So you have Ca2 plus and Cl -1. And if I didn't know that it was diatomic, I still know that I have a 2 plus charge, so I have to have 2 minus charge to equal out to 0, so it can be as stable as possible. So the final formula would be calcium chloride, CaCl2. Jumping the gun here. Now it's molecular. What does molecular mean? Nonmetal plus a nonmetal. You use the prefixes for the subscripts. What does that mean? Let's look at an example. Dinitrogen tetraoxide. 2 nitrogens, 4 oxygens. Yes, you need to know these prefixes, which is tetra means 4, di means 2. Can't forget that. They're in your notes. So let's do another example. Convert into a formula equation. Sodium chloride plus fluorine yields sodium fluoride plus chlorine. Sodium has a +1 charge. Chloride has a -1 charge. This is a atom, or well, obviously it's an atom. It is an element, so we simply write sodium. Chloride is also an element, so we simply write Cl -1. When it's a compound, together, when they form a compound, sodium chloride, it is NaCl. Fluorine, is that an element? It sure is. It's not bonded to anything else like sodium chloride is, So it's by itself. Ask yourself, is it monatomic or diatomic? It's diatomic because it is Brinkelhoff. Hoff with an F. So you're going to say F2. Yields, this is the reaction. Now you have sodium fluoride, sodium bonded with fluorine. So it's going to be sodium has a +1 charge. This is a ionic. This is ionic because it's a metal and a non-metal. That's what I'm trying to say. So you have Na +1, fluoride -1. We write that as NaF. Chlorine, it's just chlorine, so that is a element, which means, is it diatomic, monatomic? It is diatomic, so we will say Cl2. We need to make sure that it's balanced, of course, which we're not going to do right now because it's definitely not balanced. We have 2 chlorines on this side, 1 on this side. We have 1 sodium on this side, 1. Oh, that works out. But, oh, look, 2 fluorines, 1 fluorine. So we would have to balance that, which we're not going to do at the moment. We're moving on. So aluminum, is it an element? It sure is. Is it by itself? It sure is. So you write Al. It's not diatomic, it's monatomic. Sulfur, is that diatomic or monatomic? It is monatomic. So we just write its atomic symbol, which is S. Yields, now they're making a bond, aluminum sulfide. So this is a metal and a non-metal. It's ionic. So we have to get its charges. Aluminum on the periodic table is a +3 charge. Sulfide is a -2 charge. Therefore, crisscross applesauce, remember this 2 goes over here. This 3 goes here. We move on. I didn't read that last sentence because I pressed too many times. Helpful tip, keep all substances and plus signs in line with each other. Yes, notice how aluminum is directly below the word, the plus sign is directly below the plus sign, sulfur is definitely below the S, yield sign. If you line everything up, you won't get confused, you won't forget to do something. Neatness really helps in a science class, especially chemistry. Let's do another one. Zinc sulfide. Well, that's definitely a compound because you have zinc and sulfur together. Is it a metal and non-metal? It sure is. So we're going to have to go off of its charges. Zinc is a 2+ charge. Sulfur is a 2- charge. Simply crisscross applesauce. So it's going to be zinc sulfide plus, drop it down. Remember, keep it in order. Magnesium and arsenate. Well, that is a polyatomic ion. You can use your polyatomic ion sheet, of course, which means it is we are going to have to go off their charges. Arsenate gives you its charge, and so does magnesium. Magnesium is a +2. Arsenate is ASO4. Remember, you don't have to memorize that. You can use your polyatomic ion sheet. It's a -3. We get crisscross applesauce. -3 goes magnesium. +2 goes to arsenate. Mg3, arsenate 2. They react to yield zinc arsenate. Same thing. It's a compound. It's a metal and a non-metal, which is technically a polyatomic ion. Crisscross applesauce their charges. Bam. I'm going to speed up here because you can see this yourself. Magnesium sulfide, that is a compound. Show the charges. Magnesium +2, sulfur is a -2. Bam. Crisscross applesauce, MgS. Make sure it's balanced, which we're not going to do right now. Moving on, let's begin worksheet 1 for Unit 9.